artificial intelligence era. Okay, first of all, I would like to introduce to all of you our respected guest speaker from Novorian Sdn Bhd. As detailed, he is business director of Novorian and has a vast knowledge and expertise regarding artificial intelligence area. As we know, current time artificial intelligence, or known as AI, has contributed to a lot of positive things in human civilization, not only in the aspect of lifestyle, but also to the other critical elements such as education, industrial, economy, and many more. So for now, ladies and gentlemen, please give a warm welcome and big applause to Mr. Jacob Thomas to deliver his talk.
Okay, thank you, Tuan Pengerusi. And selamat petang semua. Good afternoon. So my name is Jacob. I'm from Novorian, and I was told I have 1 hour for this session, but I hope I will have enough time to cover some of the slides and videos that I have prepared. So this is a little bit about me. I've been in the industry for quite some time, and I've had many roles. And currently, I'm with Novorian Sdn Bhd as a business director. And what Novorian does, just to introduce our company to you very quickly, we do offer system integration and solutions services. So we provide three areas, basically enterprise solutions, which is mostly on open source software or enterprise open source software. Then our second category is on storage as a service. And finally, it's about AI and high performance computing, which is what our talk today is about. Please let me know along the way if you can't hear me or you have any query. I'll be happy to take your questions as well. So let's get started. For those of you who are new to AI or just beginning to understand about AI, you probably know that AI is now very widely discussed in the various medias. Ever since ChatGPT came out or was introduced in November last year, so AI has been getting a lot of attention. But AI actually has been around for many years, in fact, several decades. But because of the boom, right now they are saying that the AI market in all industries around the world is expected to hit around 13 trillion by 2030, which is about 7 years from now. So there is a big potential, and it's very relevant for most of the industries that we have today, and also for some newer industries that is going to come around soon. So as I mentioned, AI has been around since the 50s. Actually, the first paper on AI was released in 1950s, and that time was very fundamental, very basic. And as you can see, in the space of 30 years, then machine learning became popular in the 80s. That's where we had a lot of new machine learning algorithms being developed. And subsequent to that, big data also started to take up interest among enterprises. And only in the last 13 years, when AI actually started to take up rapid growth, because of what we call as deep learning. Deep learning came about around 2010 when they had a lot of new breakthroughs, and also because of the advancement of technology in computation. So as you know, AI is a very complex technology which requires a lot of mathematical computations, and deep learning as a whole takes a high amount of computation, and normal CPUs in servers couldn't do very much, or were very limited, very constrained. And when GPUs or graphics processing units became a viable option for more computational intensive tasks, that's when deep learning started to take off and become popular and widely used until what we see today. So I'll be sharing a lot more about how where we are with AI and all that. So this is a very quick definition about AI and the state of AI. So I will just skip this slide, but I think most of you are already aware about what AI is. So where is AI today? As you can see, those of you who have been active on the internet, you know there are many tools now available that can be used for various purposes for the consumer market. So you have recommendation tools, you have text and translate tools for those who are frequently going to foreign countries and want help with understanding foreign languages. There are tools to help you with that. There's what they call content generation tools, image and video generation tools, and there are also map routing, location tools. All of these different applications use AI in one way or the other. Now, this is a big market, healthcare market. The healthcare market has been the beneficiary of AI in the early years in various areas. For example, medical imaging. So doctors or hospitals that have a high volume of x-rays find that they don't have enough radiologists to actually go through and inspect or examine all the x-rays well. So they have started to use AI to look at x-rays and to detect potential problems that the normal human may have missed. Because of the volume of x-rays, it's normal that the human will become exhausted and may miss certain things. So the machine with deep learning be able to get a more accurate interpretation from the x-ray. So, and that has been already going on in a few countries. And we also see AI or deep learning being used in biomedical research. I have a video about that after this, which I can share. Those of you who are doing molecular what do you call molecular engineering and all that, or doing more science related to biology and chemistry, will understand what kind of areas that where AI is being used. Pharmaceuticals, in drug discovery, there's also heavy use of AI and deep learning as well. So to take on further, AI has also been used in algorithms to detect certain illnesses like autism. So based on patterns that they find about on the autism patients, they can see there are certain fingerprints in the brain from the MRIs or from the X-rays where they can predict there is a high probability of autism in a patient. And in the same way, in the other one, you see about uh, what they call genome sequencing, where they use a lot of heavy duty computational with AI to sequence DNAs and also to predict or to diagnose any issues related to on the genetic levels. So with the growing interest in AI for healthcare, a group of experts around the world actually formed a community, an open source software community, to develop a medical AI framework, and it's called Monai. And it was developed started development in 2019, and it took about a year. So during the pandemic, they were still fine tuning it, and they released the first official version around last year. And since last year, a lot of hospitals have been using it, and what it does is that it helps in six different areas. It can help to generate synthetic data. For those of you who are familiar with AI, the way AI works is that you need to train the AI models with the data that you can collect in order for you to understand the problem or the issue that you want to resolve with AI. Then you have labeling, you have training of the models, you have federated learning. Federated learning was highly used during the COVID pandemic. I'm not sure if you followed some of the news that were going on when they were looking for a potential cure for a vaccine for the COVID. Um, Researchers in several countries who had their own data about COVID patients in their respective countries wanted to collaborate to see how they can work together to combine their data and find a vaccine. So what they did was they used tools like Monai, where the data is proprietary to the respective country, but the model is shared. The model is shared. So let's say, for example, a researcher in Japan has got data about COVID. He uses the tool to develop the model. That model is shared with other researchers from other countries. And together, when they combine the models, they have a bigger and more accurate representation of the uh, of the what do you call of the problems within COVID patients, and how to build a vaccines to address all the different possibilities. So that's one of the ways they used during the pandemic. Then you have also other areas where Mona is used for translating AI models to applications. I have a video that I will can play for you after this. So what Mona does is that it provides pre-trained models in various areas for doctors and hospital folks. So you have areas like pathology, you have radiology, you have endoscopy, X-rays, MRIs, and so on. So all these are pre-trained and available. So when you download the Monai software, all of these modalities and applications are already available that you can use right away. So here's a video that can explain how hospitals use Monai in some of their day-to-day activities.
In surgery in general, and neurosurgery specifically, you can fix what you can see. Therefore, visualization is critical in our work.
If you're able to interact and visualize that patient's images, you're better able to plan the correct intervention and make sure that you apply the right intervention the first time.
It's a way to see Monai as a toolkit which is dedicated to AI in imaging.
So Monai is a community-driven effort to bring data science into the clinic. And that's everything from the development of data-driven products and the curation of data to then how we get those insights in front of clinicians looking after patients.
Since adopting the Monai infrastructure, it's freed us to focus on application to specific clinical problems and catalyzed that application in multiple directions.
What we can do through Monai is that be able to segment the tumor, segment all the critical structures around it, and in surgery provide real feedback data to navigate the surgeon around the tumor to make sure most of the tumor is removed. Therefore, we're providing the patient with the most benefit.
What Monai then brings is the final layer on top, which is a way to scalably apply artificial intelligence across that entire medical record, across every patient pathway. The potential scale of that is massive. I can see Monai in every clinic, in every hospital across the world.
Okay. Azim, can you hear me okay?
Okay, Mr. Jacob.
Yeah, okay, all right.
Very clear.
All right, thank you. So that was a video about Monai, and let's move on. For other markets or industries where AI is being used, here is an industrial market. This is related to probably those in manufacturing industry. You have AI being used for factory inspection, for example, defect detection. So a lot of manufacturing companies use manual methods to check for defects in their products. So with AI, you can actually use a high precision camera and inspect the finished goods for any defects in a faster way, because you can train the AI model to understand the various defects, and it be able to look at the defects faster than what a human can do, and it also doesn't complain or getting tired, so it can do constantly around the clock 24/7. So that's one aspect where AI is used. The other one is field inspection. I think you may have seen cases where people use drones to go out in the open field, for example, electrical towers where they have inspections to do, and instead of getting a human to go up the tower, they get a drone to go up, and the drone is fitted with a camera, and with that camera they're able to snap images or look at the videos that is being streamed back, and then identify possible areas for problems that needs to be fixed. So this will reduce the manpower required and also the time taken to do such inspections. And then the last one is on predictive maintenance. This is an interesting area, especially for those industries where machinery downtime is very costly. For example, you take oil and gas platforms in the sea. As you know, Petronas has got many platforms out there in the sea, and they have very huge machines running on the platforms. And if any of the machines were to break down or become unavailable, their losses are going to be humongous. So what people or some researchers have done, and we know there's a few projects by a university here to help in such areas. Machines will configure the machines to send their sensor information to a system, an AI system, which will then process and predict when a maintenance is needed or when a failure will happen. So usually, from what we were told, they can predict at least 3 days to 1 week in advance before the failure will happen. So what this does is that by knowing this information, they can get the spare parts available on the oil platform in the sea. And these platforms are at least 200 kilometers into the sea. So when you wait for something to happen and then you ask for parts, the turnaround time could be at least a day. So by knowing this in advance, they can actually request the spare parts or do some proactive action to prevent the failure from becoming a big problem. So they save a lot of avoid a lot of losses by using AI. This is another example in a production environment or in a manufacturing environment where robotics are used and to move things around, like in large plants or even in warehouses. So they have this kind of mobile robots which are able to maneuver themselves around the plant or around the warehouse, and they know exactly where they need to go based on the training and the model that they have built. So this is another application. Then we have agriculture market where AI is also used for harvesting and for providing more modern ways of farming with the use of robotics for certain use cases. So I understand the government is also looking at modernizing our agriculture sector, and UPM, I was told, is part of that process. So that's good. So maybe there will be some elements of AI that UPM can also look into to help our farmers and our agriculture sector to modernize their practices. Then in the transportation market, this one I guess most people already know. We have autonomous vehicles available already. Tesla is a big brand, big name in this space, but we also have other brands that are coming in very strongly into the autonomous market. In fact, in the US, we just got a news in last month that Mercedes-Benz has become the first brand to get approval from the US government to provide level 3 autonomous cars in the market, to sell those kind of cars in the market. So if you're familiar with autonomous cars, level 3 means the car will drive on itself and the driver must remain seated on the driver's seat, but you don't have to look at the road. You can do other things. You can watch a movie, you can do texting and so on. So level 3 means the car doesn't require any manual intervention unless it senses some emergency or some danger, that then it'll warn the driver to take over the control. So what we know is, like our Proton X50, we have level 2 autonomous features where you still need to the driver still need to pay attention to what is happening. It won't allow you to take your eyes away from the road. But in level 3, you can actually do something else. But you cannot like read a newspaper. You cannot block the view of the road, but you can do other things. You can take your eyes away from the road. So that's already approved. And Mercedes, you can look it up in the YouTube. They have a video of their Mercedes car with this feature. It is going to be rolled out in the US very soon. Okay, in the financial industry, AI is also widely used for fraud detection, for risk management, for chatbots, for example, for customer service. These are all traditional ways where AI is being used, and then also for prediction. So in financial markets, forecasting is a very important activity where they need to forecast or predict. Like for example, you talk about exchange rates, for example. So exchange rates movement, if they can predict in advance, maybe what's going to be the exchange rate within the next 3 days or within the next 1 week. They are able to plan better and do necessary activities to take advantage of the movement of exchange rate. So these kind of activities are where AI is widely used in financial sector. So now I will talk about another area where AI is heavily influencing, which is in scientific computing. And those of you who are involved in sciences, in engineering, you will probably find some of this information relevant. So firstly, this is an example of a biology research on microbiome. I'm not sure if you're familiar with microbiome. It's one of the study of the gut, our human gut, the bacteria in the human gut. So there was a study in this field, and the researchers who did this study, they compared the performance of uh, doing their research, because the data is very large. So they used, at first they used a normal piece a server with a Xeon CPU, which is a server grade CPU, and they took like 8,000 hours to complete the processing for the largest data size that they have, which is about 300,000 records. But when they moved the job into the latest GPU, which is from NVIDIA A100, the same job took only 1.4 hours. So this is the kind of acceleration that the scientific community is experiencing. And this by the way, this article was in 2020, in a conference in 2020. So it probably happened 1 year before that. So since then, a lot of new changes has happened. So this is where we see the high performance or scientific computing or high performance computing market moving. And we also have AI and HPC or scientific computing converging in certain research areas where prediction is necessary. So like, for example, in weather modeling, in climate change, now AI is being used to predict how the weather will be in the next, for a longer period. So normally we have weather forecast, which is usually given for the next 2 or 3 days, or even maybe 4 days. But with AI, they can predict even longer, especially for countries where they have very violent weather. Sometimes they have typhoons or even tornadoes and so on. So they can predict the chances of something like that happening way in advance, and they can give early warning to the people who might be affected. So this is another example where HPC and AI came together. This was done by DeepMind. DeepMind is a subsidiary of Google, and they looked at one of the biggest biology problems, which is determining a protein's 3D shape from its amino acids. So this involves a lot of prediction. So this problem was unsolved for a long time, but DeepMind found an algorithm and a way to address this problem using AI, and they managed to predict the relationship between the amino acids in the protein structure. And by doing that, they actually answered a lot of questions that were still unanswered in the scientific world relating to protein and amino acid. So this was a paper that was published in the Nature magazine somewhere also in 2020. Okay, and another area where AI and HPC is converging, if you see this particular slide, is in parameterized design, or in engineering design, where engineers are constantly looking for better ways or to improve their design to make whatever product that they're doing operate better or more enhanced in its operation. So, and a lot of rules of physics are applied. So, for example, there's a video about this, which I cannot share today, but there is a video on YouTube where they were trying to design the best heat sink to dissipate heat from the server. And because the flow of the hot air inside the server is in a particular way. So the heat sink needs to be designed in such a way that it maximizes or optimizes the dissipation of heat. But in order to find the best design, they need to know how the heat is flowing. So by using tools like NVIDIA Modulus, and also by using other design tools like Omniverse from NVIDIA, they are able to create a simulation of the flow of hot air in the server. And from that simulation, they will be able to see what happens when they do a particular design of the heat sink. So by doing various trials, simulated trials electronically without actually building a real prototype, they are able to try out different design combinations to see which one is the most optimum for dissipating the heat. So there is a video about that. You can take a look on that. So the benefit here is that the AI is helping them to predict how things should be like based on the changing scenarios that they may encounter in their design. So here's a good video for you to look at how the laws of physics are applied in a simulation with AI factored in. So this is about planning how to do a 5G network. So this was used by Ericsson.
There are 15 million 5G microcells and towers planned for global deployment in the next 5 years. Ericsson is using NVIDIA Omniverse to build digital twin environments to help determine how to place and configure each of their sites for the best coverage and network performance. In Omniverse, Ericsson builds city-scale models that are physically accurate down to the materials of the buildings, vegetation, and foliage. Then, wireless network components are added, including the precise location, height, and antenna pattern of each transmitter. Ericsson built a custom Omniverse extension, enabling them to integrate radio propagation data and leverage Omniverse's RTX accelerated ray tracing to quickly visualize and calculate the quality of the signal at every point in the city. Because Omniverse materials are physically accurate, the intensity of reflections are precisely determined. Antenna beamforming and signal paths can be accurately simulated and visualized. In the simulations, the lobes signify transmitter antenna beamforming, and the straight lines are signal paths. The colors of the signal paths denote strength in decibels and data throughput. From blue is the weakest to red is the strongest. Visualization is a critical capability for Ericsson. With Omniverse VR, network engineers can virtually explore any part of the model, teleporting to any location, anywhere in the world, at one-to-one scale. As they tune the network for optimal performance or identify path disruptions, they can literally see the effects of their adjustments in real time, things which aren't visible in real life. In Omniverse, Ericsson can perform true-to-reality remote simulation of entire 5G networks, enabling them to design more efficient and reliable networks, conduct remote field trials, and speed up deployments.
Okay. So I hope that gave you a better idea about how AI is being used in 5G network planning. So you could see that you could see that they tried different positions and different ways to get the most optimum signal coverage as part of their design planning. So all these tools are actually changing the way scientists do their work. So those of you who are into sciences or do experiment in engineering, you know that the traditional way is when you want to do a scientific validation, you have observed data, then you create a hypothesis and you test the hypothesis by doing a prototype, or you develop the model. But with the simulated way using AI, so now you can you change the approach slightly, where you create a simulated electronic model using the software like Omniverse or Modulus, and then you train using the physics rules that you want to apply to the model by using AI. So all these physics rules, for example, in the case of the 5G network, there is always the different signal strength is influenced by location of buildings, by reflection, and by maybe even plants or trees nearby. So these are all the different physics rules that you can actually factor into your model as part of your simulation. So it's not just doing an artificial simulation, but it's actually doing a very realistic simulation in the real world. So based on that simulation, then you can validate your theory or the data that you have collected and come to a conclusion. So that's all already been happening for the last easily for the last 3 years or even longer. So, but today, as I mentioned when I first started this talk, ChatGPT was the actual turning point for AI in the world, and everybody now from from the most renowned scientists to the most Joe public will know about ChatGPT and know how to use it already. I'm sure all of you are also playing around with it. But what that brings about is there is a generation of new technologies called generative AI and large language models. ChatGPT is actually developed based on large language models, the underlying technology behind it. And these are not new things. This has been around, they have been around for quite some time, at least within the last 5 to 8 years. But it has been refined and became better. So where generative AI sits is it's within a subset of deep learning. So earlier in my earlier slide, you saw that deep learning was started in 2010. So generative AI started probably the first pass of it probably started about 2 or 3 years after deep learning started, but that was the early years and very little was known about it. But people have then managed to develop and improve the algorithm and to what we are today. So what the way ChatGPT works is also a form of generative AI where it's able to predict and look for the responses that best suits for your question or prompt that you are asking. So, how is generative AI used in some industries? As you can see, in the drug discovery world, they are using generative AI to predict 3D protein structures and also generate biomolecules for protein sequences. So, those of you who are familiar with proteins, you know what they mean by protein structures and molecules or protein sequences. So, those of you who are not familiar, this is what I heard from a friend. So I'm not an expert in this area, but I will tell you what this person told me. Protein sequences are basically two-dimensional combinations of protein of what they call, there's a scientific term for it, I can't remember right now, but it's basically a two-dimensional object, whereas the 3D protein structures are, as it is 3D because it has many different protein sequences that gel together to build the protein structure. So, but in order for this, why this is a challenge in drug discovery, because it's not an easy job to find the right sequence and the right structure in order to generate the right drug, to build the right drug. So because there are so many different combinations, and scientists usually take a long time to solve or find the right combination. But with AI or with generative AI, they're able to cut short the time and able to do different iterations on using simulation. There's a video after this that you can see, and they are able to get the results faster. And I believe this was one of the methods used during the COVID pandemic to find the vaccine. So the next video will give you an indication, an idea about this.
Drug discovery is incredibly hard. Bringing a new drug to market takes more than 10 years and has just a 10% success rate. Between the complexity of biology and the near infinite chemical and protein combinations, discovering drugs to help cure disease is a truly heroic endeavor. Accelerating this process is mission critical for drug developers. There are 3 key stages to drug discovery: discovering the biology that causes disease, designing new molecules, whether those are small molecules, proteins, or antibodies, and finally, screening how those molecules interact with each other. Today, generative AI is transforming every step of the drug discovery process. NVIDIA BioNeMo service provides state-of-the-art generative AI models for drug discovery. It's available as a cloud service, providing instant and easy access to accelerated drug discovery workflows. BioNeMo includes models like AlphaFold, ESMFold, and OpenFold for 3D protein structure prediction, ProteGPT for protein generation, ESM1 and ESM2 for protein property prediction,
megamole BART and MoFlow for molecule generation, and DiffDock for molecule docking. Drug discovery teams can use the models through BioNemo's web interface or cloud APIs. Here's an example of using NVIDIA BioNemo for drug discovery virtual screening. Generative models can now read a protein's amino acid sequence and, in seconds, accurately predict the structure of a target protein. They can also generate molecules with desirable ADME properties that optimize how a drug behaves in the body. Generative models can even predict the 3D interactions of a protein and molecule, accelerating the discovery of optimal drug candidates. With NVIDIA DGX Cloud, BioNemo also provides on-demand supercomputing infrastructure to further optimize and train models, saving teams valuable time and money so they can focus on discovering life-saving medicines. The new AI drug discovery pipelines are here. Sign up now for access to NVIDIA BioNemo service.
All right. So that was about generative AI in drug discovery. Now, apart from the drug discovery or pharmaceutical world, you have also see use cases of generative AI in financial services. So this is possibly in areas where related to chatbots, like what ChatGPT is doing. It can predict or generate responses for the customer based on the prompts that they're getting. Or it can also look at detecting, preventing fraud in real time, not after it has happened, but while it is happening. So it can it can help prevent bankers or banks from encountering any losses, and it also can provide smart trading decisions. So this is providing insights into investment portfolios that you might have. So these are ways how generative AI is being used in financial services. In education and research, this I suppose everybody should be familiar. You can use the generative AI or large language models in research projects where language is required or where speech recognition is needed, and large language models can be useful. Or even in chatbots like what you see in ChatGPT, you just need responses. You don't need to hear speech. You can also use generative AI and LLMs. So, what I know is most of the students today are also using ChatGPT to come up with their assignments and reports and so on. But I think there are tools to help lecturers to check for such things. In public sector is also the same. Generative AI is being used in all these areas, again to help public with inquiries, online inquiries, help policymakers do better decisions, go through the documents and break down the content or the points in the documents in a fast way. So there are many ways where generative AI is being used. There are many other examples that you can look up. So what makes all this possible, or all these AI technologies possible, is the underlying hardware and software that actually drives all this. For example, ChatGPT, which was announced last year, was actually developed over at least a couple of years, and they managed to do it because they had the access to a very compute intensive machine with over 10,000 NVIDIA GPUs. So GPU, if you know, we're not talking about the gaming ones. Those are for games, but these are the ones used for heavy duty compute intensive activities or processes. So ChatGPT actually basically trained their models for many weeks on these GPUs, and finally to the point when they were ready to release it last year November, and they're still improving on it as we speak, using new models that have come out since then. So I will now cover a little bit about the underlying platform that supports all the various AI, HPC technologies that I shared earlier. So if you're familiar with NVIDIA, so NVIDIA is one of the largest companies in the world with a heavy focus on AI, data science, scientific computing or high performance computing. And so they have a combination of hardware and software. So when it comes to hardware, I'm going to start with the hardware. There's an end-to-end product line. And NVIDIA is not the only company doing this. There are also companies like AMD and IBM and a few other smaller companies are doing similar hardware products, but they may not have the entire end-to-end line of solutions. So if you buy a laptop today, you will know most likely you have a GPU inside, and you can also put the GPU in a workstation, in a server, or even in a robot. So the GPU in the robot is obviously different. And even for autonomous cars, like you find in the Teslas and others, they also have a GPU inside that actually looks at the data from the sensors to do computation. So that's how it can make decisions whether it needs to move left, right, keep on going straight, stop, and so on. So all that computational activities is happening inside the GPU, inside the car. So as far as AI, data science, high performance computing is concerned, these are the solutions from NVIDIA. You can find the first two are the high-end models with 8 GPU cards inside. And it's an engineered solution from NVIDIA, which is only available from NVIDIA, which comes with support and so on. The last two, the third and the fourth one, these are just the motherboards with the GPU card, which you can put into another server from somebody else. The only difference is that the server provider will need to support the hardware. There's no support from NVIDIA at all. The key factor here to know is that the NVIDIA boxes, the first two, the support covers both hardware and software, because the software is actually the key ingredient to making all the different simulations possible, while the third and fourth option is the hardware is supported by the respective hardware vendor, but the software there's no support and you are on your own. Okay, so what is unique about these two boxes, these two hardware, the A100 and the H100 boxes, is that they have this feature called the multi-instance GPU. Previously, if those of you have been using GPU for many years, you know that once a user uses a GPU, the second user cannot use the GPU because until the first user finishes. So, but in the new models of GPU, you can actually have up to 7 users on a single GPU. So the GPU can be shared. So by having more users on a GPU, the amount of memory each user gets is divided equally. So for example, if you have a GPU with 40 gigabyte of memory, if you have 7 users, then each user only gets 5 gigabyte of memory. So that is how the GPU partitioning or multi-instance GPU feature works. So this is a good thing because now you can have more people sharing the use of a GPU instead of the traditional where one GPU is only can be used by one person. Then this is the support that comes with the NVIDIA products or hardware. So the support is including both hardware and software. And more recently, NVIDIA introduced the DGX Cloud. So the cloud is basically something new that was announced only like 3-4 months ago. So there's more information that is forthcoming, but basically what you get is a DGX, but parked in some cloud, maybe the Google, Oracle, or Microsoft Azure cloud. And the costing and all that there will be terms and conditions to follow. So, but basically, if you don't want to buy on your own, you can use on the one in the cloud for any workload that you want to run. And it comes with all the NVIDIA expert support and so on, all available as well. Okay, those solutions I spoke about were the bigger machines. Now, if you're buying individual cards or GPUs, they have different type of GPUs available. So depending on what workload you want to run, the first column you see is the workloads related to AI, deep learning, or high performance computing. The second column, the last column is related to workloads where you need graphics or visualization together with deep learning. So when you have graphics built into the GPU, the performance of the GPU for AI is lesser, but you have additional features like the graphics. So if you want to have a better idea which GPU to use for your workload, this is a good table to refer to, where every workload is listed here, starting from deep learning training and analytics, and also inference and HPC, all the way up to for embedded computing or robotics. You have different workloads where you can choose the right GPUs to suit the workload that you want. Okay, so why do people bother to use a GPU? So this is a good example here, where if you have done any work on developing models for AI or even for data science, doing processing of data using data science algorithms, you know that the entire work is actually iterative. So you need to wait for your output to come back to you to see whether it meets the requirements or the accuracy level is good enough for you to use it for actual inferencing purposes. But because if you use a CPU alone, this first chart here shows if you don't use a GPU, just a CPU, the time it takes for the job to complete is very long, and you only can do, in this case, if you see the green boxes, there's only, you can, in the one work day, you probably have only 3 attempts that you can do to do your processing, because maybe the first attempt you find there was a problem, then you try the second attempt to fix the problem, and then the third attempt is to fix another problem or fine-tuning your model. And so this is an iteration that keeps going on, and because the red markers are the time taken by the CPU to do the processing. But if you use a GPU, and because GPU is very fast, the time taken to do processing is very little, and therefore you have more time to complete your testing and iterative experiments. So you can see the green boxes here. You have at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different attempts you can do within the same amount of time if compared to just using CPU. And that is why GPUs are very popular for AI, for data science, for scientific computing, because of the extreme acceleration that you can get. So this is another slide that where the value of the NVIDIA DGX box is shown. You can actually basically replace 300 servers, performance of 300 servers with one DGX box. So that is the same amount of computational power that you get for AI, data science, and high performance computing workload. So that is a tremendous amount of savings in terms of space, in terms of power, and in terms of cost. So hardware alone is useless unless you have the right software to drive it. So this is another value add from NVIDIA, where the software for the various different workloads that you want to run, whether you're doing vision computing or you're doing language or you're doing scientific computing with engineering, or you're doing generative AI and so on, you have different software for different purposes, and I'll run through some of the software here. Firstly, the AI collection of software. You have different software for different AI workloads. From medical imaging, which I showed earlier, you have the what they call as the Clara list of software. For speech and conversational AI, you have Riva. So this is Riva. This is basically for speech AI, where you are able to get the AI model to respond to maybe if somebody were to give a set of text, and it can respond back in terms of speech, or if the input is speech, it can also respond back in terms of speech as well. So the AI model is able to comprehend the different language. There are models for English, there are models for various European languages, Spanish, Portuguese. There's also models for Mandarin and so on. There are many languages supported, in one Bahasa Indonesia, and Bahasa Melayu is also available. There's a few companies in Malaysia doing that. So Riva is one of the software development kits that can be used for this purpose. There are many other options in the open source world. You don't have to just use Riva, but the benefit of using Riva is that it has already got a lot of built-in APIs that you can use, and the support is also provided. So there is a free version of it, but with limited features, and the full-featured one comes with support and annual subscription. But there are open source versions of the similar software with probably different features. Another software here is for cybersecurity. where GPU is being used because of the amount of cybersecurity attacks happening regularly. It is impossible for any organization to completely stop all cybersecurity attempts unless you have got machines to automatically detect and prevent such attempts. So when in environments where these attempts are happening on a regular basis or very high volume basis, a normal CPU may not be able to cope. So that is where GPUs come into play, and the software that works with the GPU is called Morpheus, and you can look at the various attacks in coming in terms of phishing, in terms of fraud detection, ransomware, behavioral patterns. You can even analyze the data in terms of the behavior of the user to see whether the person is doing something naughty or not when he's accessing the system. So there's a video also on this to guide you and explain further how this works.
These hexagons represent the network traffic of a 25,000 employee global company. Traditional cybersecurity focuses on pattern and threshold-based alerting, while identity-based attacks revolve around identifying anti-patterns. Detecting these deviations in 900 terabytes a day is extremely difficult. Here, a recently compromised user account starts performing highly atypical yet still permissible enterprise actions. Traditional security methods do not trigger an alert. This single compromised account then pivots to expand access and to make it harder for defenders to eliminate. Eventually, a traditional alerting mechanism triggers and the security team promptly shuts off access. But not before company operations are impacted. Valuable IP, only representing an easily concealed 0.1% of the daily traffic volume, was already compromised and shared with the world. Clearly, traditional mechanisms were not sufficient. What if the enterprise had deployed Morpheus? With the Morpheus digital fingerprinting workflow, every network event is scored, organized by user, and prioritized in near real time. From hundreds of millions of events a week, a security analyst now sees the top 10 potentially actionable alerts and, crucially, detailed context that determines effective next steps. Let's rewind that previous scenario and see what happens this time. With this massive data reduction and contextualization from Morpheus, anti-pattern behavior is quickly surfaced. The initial compromised accounts are promptly shut down before substantial pivoting occurs. Breach response is reduced from weeks to days, and what could have been a massive incident is stopped before significant damage occurred. The original scenario wasn't just inspired by real events, but illustrates the actual breach that happened to NVIDIA in early 2022. Morpheus is able to quickly detect such specific anomalies because digital fingerprinting learns the typical network behavior of organizations' users, systems, and applications. The fine-grained models are tuned to each individual, like a fingerprint, mapping how they interact day-to-day with complex enterprise infrastructure. Available on NVIDIA NGC and GitHub, Morpheus also runs in all major clouds. You can also get immediate short-term access to pre-built use cases and pre-trained models, including digital fingerprinting on NVIDIA Launchpad.
Okay, so if you're wondering what is AI got to do with cybersecurity, the video actually mentioned that AI is being used to predict behaviors or predict patterns that are happening in the data streams that are being monitored. So when you talk about security, you have, for example, various log files or even real-time data or network status that is being looked at. So various combinations of data is being looked at the same time and then correlated, and prediction is being made whether there is a behavioral pattern happening that needs to be looked into or even stopped. So there are things that the software is doing with AI to basically prevent any attacks from happening. Okay, so Merlin is another software available from NVIDIA for recommender applications. Recommendation tools are quite widely used today. If you shop online, for example, you know that there is a recommendation engine that always looks at your behavior pattern of buying things and then recommends something else for you to buy. So there are, I think the companies like Amazon and the bigger e-commerce providers like Walmart and all that, when you buy online, they will know your pattern of buying, and they will be able to recommend something that they think, or the machine thinks that you would like to have. So these are tools that is available for recommendation application. Clara, I already mentioned earlier, this is related to the healthcare. All the tools that you have, including Monai, is part of it. So there are different tools for different purposes. So you have one for imaging, one for genomics, one for structures, simulation, and so on. So there are different modules available for different purposes. Rapids is another software. This is primarily focused for data science. If you're working with things like pandas, scikit-learn, numpy, these are all traditional data science APIs or libraries that are being used for doing processing. But in the traditional data science libraries, they are all designed to work for CPU. But in the Rapids, they have the equivalent of Panda, scikit-learn, and NumPy and others that runs on GPU. So if you have an existing code today written in the traditional way for the CPU using Panda, NumPy, and scikit-learn, the same code can run unchanged in Rapids, but with a GPU processing done. So what you will see is a rapid increase of performance. So here you can see the comparison being made between a CPU and a GPU. The top lines are the CPU nodes, and then the bottom is the DGX nodes with 8 GPUs and so on. But if you can extrapolate this to if you're using a single workstation without GPU and you use another machine with its GPU, you will see a significant performance in speed as well for ETL, for any of the processing, for machine learning and so on, and visualization as well. Then for scientific computing, those applications that are related to sciences, to engineering and all that, there's a different set of software available from NVIDIA for high performance computing, where you have programming models in Fortran, where there's mathematical computations, you have mathematical libraries. Those of you who are from Inspem, you might know some of these libraries for for example, algebra. This is one for algebra, one for CU sparse. I forgot what it stands for. There's Fourier transformation, FFT, and many more different libraries available for those applications that require mathematical computations or very intensive mathematical computations. There are libraries available from NVIDIA for those use cases as well. Now, for autonomous cars, this is the software used for training the cars to look at the various conditions out there. So it's called NVIDIA Drive. So it has got different modules for perception, mapping, planning, and so on. And it also got supporting tools called for sensor abstraction. So it will be able to collect the sensor data. It will be able to do the LiDAR connection, the radar connections, and then use these data to basically process it and help the car make decision on what to do next. And obviously cars, it has to be processed very fast, because decision has to be in split second. So you cannot have anything slow that will then cause danger to the occupants of the car. So these are the different use cases that the Drive software does. So you can see these are the different driving conditions: daytime, nighttime, snow, different obstacles on the road, traffic lights, pedestrian. You may have even different roads without signs, and roads with very low lighting, or when you want to park and so on. So there are different kind of use cases where the software is already pre-trained, and you can also train it to do additional things that you want it to do. For robotics, this is a software called Isaac for simulating the robots in the electronic environment before you do the actual in the real world. So you can actually have a simulated robot in your system to do the task. If, for example, you wanted to pick up something or drop something or move to left, move to right, and you can train the robot to do it inside the system and inside the Isaac system, the simulation platform, and then you can copy that same simulation to multiple robots. So you can in one go you can train hundreds of robots to learn the same thing, and then apply that model into the robot for in the real world, and you can see that it is able to learn immediately on the actions that it has been trained on. So there are many other softwares available. These are all downloadable from NVIDIA's software repository called NGC, or NVIDIA GPU Cloud. So I won't go into the specifics of it, but there are many different softwares depending on what you want to do. There's also training available from NVIDIA. So all these tools that I talked about, the hardware, the software, the containers, the NGC, the training, these are all part of the solution offering that will help anyone who wants to do development in AI, data science, high performance computing to do and achieve what you want to, you desire to get. So my last few slides, I hope I'm doing well on time. So this is what is going to come down the road, maybe even starting this year. So so you are seeing more and more convergence of HPC and AI, and in what we call digital twin. If you may have heard of this term, digital twins, a lot more industries are now using AI to do simulation of their production real world environment before even doing anything in the real world. So if there is, for example, BMW, the example I mentioned earlier, before they build a plant in the real world, they will actually build a plant in the virtual world, in the multiverse, so to speak, and they will be able to simulate the different operational activities in the virtual world and fine tune and optimize it so that they can basically reduce the cost of making errors in the real world. So by doing these things on the virtual world, they are able to learn from it and then improve on it and enhance it further. And then when they do it in the real world, they can get it right straight away. So there's a lot of training going on with AI, with a lot of physics rules being applied using the modulus software that I mentioned. There's synthetic data, because in some cases you may not have enough data. You can use this software to generate synthetic data to help you in your AI training and prediction. Then the other thing that I mentioned is the federated learning. This is something that is going to happen more and more, where many people in different parts of the world have their own data, but they don't want to give away their data. So what they do is they are able to use federated learning to build their own AI model and then just share the model with other researchers, and the other researchers can do the same, vice versa. They can share their models to others as well, and everybody can benefit by having combined expertise and combined data points without actually sharing the data itself. So it's just by having the combined knowledge and from the trained models. So that's called federated learning. Now this is a new development in terms of on the hardware perspective. There's a new processor in the market called ARM. Actually, it's not new. It's been around for several years already. So NVIDIA is moving in that direction where they're now changing the way CPU and GPU. If you know, currently CPU is separate, GPU is a separate item, two different items. But in the new product, the CPU and GPU is going to be in one physical product. So you don't have to buy two separate items anymore. It comes as one physical product. So using the ARM CPU and the NVIDIA GPU, you have one physical product. So in order for that new product to work, they have built a new set of software as well to support ARM and the GPU. So this is already being demonstrated, and the first release of this new hardware will probably be sometime end of this year. There are already plans going on right now. So that will make things, the bottom line is by having these two products together, the performance will increase tremendously compared to having it as two separate, because within the data transfer between CPU to GPU, there is also some lag because it's two different products. But when it's combined together, data moves at light speed. Okay, and down the road, quantum computing. This is already, I think, some announcements are already happening. Some companies are announcing. Google recently announced something that they have got something in their labs ready. Nvidia is also doing something, and they have got a lot of potential. And quantum is going to take the next jump, next leap in computing. So those of you who are working on compute intensive kind of projects and all that, maybe quantum is something you want to keep an eye on. The softwares are slowly coming out, and Nvidia has also released their own software called Quantum. So there are different modules already available for the various processing using quantum computing. Finally, I want to share some news about what's happening in around this region in ASEAN. So this is Vietnam. Vietnam is actually one of the biggest users of AI in this ASEAN region. Singapore, Malaysia is sadly on, I think, fourth or fifth in this region, but Singapore used to be number one, and probably still is number one. But Vietnam is catching up very, very fast, and this is one example which happened in February this year, where they deploying AI-based healthcare models to 100 plus hospitals, and these healthcare models were trained by Vietnamese researchers using the DGX Superpod. DGX Superpod is the DGX product that you saw earlier. They have I think about 20 of those DGXs, and they're using the DGX to do healthcare AI models. At the same time, they're also using it for other things. This Win Brain is a subsidiary of a bigger company called Win Group. Win Group has got businesses in retail, in automotive. They make cars as well. So they're also making autonomous cars using the same Superpod DGX. They're training cars for their own cars. They also got retail supermarkets. They got retail chains. So they're also building AI there. So they're doing many different things with AI, and there are many companies in Vietnam also doing the same thing. So this is just to give you an understanding what Malaysia needs to do in order to catch up with our neighbors. So our neighbors are really moving fast in this space. So that's all I have for today. I hope you have benefited from this presentation. Please let me know if you have any questions. I'll be happy to take any questions that you might have. Over to you, Azim. Thank you.
Thanks, Mr. Jacob, for very interesting information and knowledge that shared with us just now. So for now, I will open a Q&A session. I'm sure most of participants will have some question that keen to be shared with Mr. Jacob.
Yeah, please go ahead.
Any question from participants?
Yeah, you can ask me in Bahasa or in English. I'll be happy to take your questions.
So any question?
Or maybe it's not very clear. Anything that is not clear, yeah, feel free to ask if there's something you want me to repeat or was not clear.
Okay, Mr. Jacob, I have one question about AI.
Okay.
So about artificial intelligence in Malaysia. So far, AI support for Industrial Revolution 4.0. So is it most of the technological or industrial company in Malaysia use AI implementation in order to make them be more innovate and so on?
Okay, when we talk about Malaysian context, you have to bear in mind Malaysia industries, private sector. I'm talking about private sector industries. 95 to 97% of them are small micro companies. Only 2 to 3% are the large companies. So as far as AI is concerned, the large companies are doing something. They are using AI to some extent. Some are doing more than others, but they are using it. But the small, medium companies, they are still not there yet for many reasons. Number one is probably they don't have the expertise or number two, they may not have the funds for it, or the understanding, or even their business may not require something like that yet. But as we move forward, I think the government today is trying to get more more innovation done. So there's more initiative by the government. So there will be a push from the government, and I hope that will encourage more of our industries to look at AI favorably and apply it. Of course, there is also the big concern or fear that AI is going to take away our jobs. That is always there. I think if you look back 30 years ago in 1980s, when computers first started, that same argument was there. Oh, is computer going to take away our jobs? So those days before computers, everybody doing things manual. When computers came, they thought they're going to lose the jobs. But then everybody adapted, everybody found new ways to do things, and there were new jobs to do. So the job market more or less balanced each other out, and not there were no massive unemployment after the computers came on board. So the same story for AI. I think there will be there will be a rebalancing of the ecosystem a bit. Everybody will still have a job, just you won't be doing the same thing. You may be doing different things, but you will learn as you go, and you will adapt as you go. So I don't think there is any reason to fear for that purpose lah.
Okay, thanks, Mr. Jacob,
Yeah.
for the interesting answer. Okay, so any participant, any question? Other participants? Okay, Mr. Jacob, I think there are no question.
Okay.
So we would like to express a million thanks to Mr. Jacob Thomas for allocating his very limited time for us to enlighten and entertain excellent presentation on the impact of AI influence in human life. Okay,
No problem.
thank you very much. Very nice presentation.
Thank you. You're welcome.
Thank you, Mr. Jacob.
Thank you. Thank you. Thank you for your time.
Okay,
Yeah.
thanks to all participants.
Thank you, everybody. Have a nice weekend.
Thank you so much, Mr. Jacob.
Thank you. Well, before I forget, Azim, if anybody have any questions, you can also email me.
Okay, Mr. Jacob, I will let you know.
You have my email. You can just share it for anyone who has anything they want to ask.
We just directly email to you lah.
Yeah, they can email. No
Any
problem.
questions?
Okay. All right then. Thank you.
Thanks,
Have a
Mr.
nice
Jacob.
day. Bye.
Okay, bye.